So we have our data uploaded and we have our images installed and our commands enabled, the commands that trigger the processes that we want to run on our data. And so now the next thing to do is to actually start launching some containers and getting some results back. So right now I'm logged in as a member, which has membership access to our COVID-19 AR project. This is a user that I added. It's not part of the demo necessarily. So let's go into this CT session and see how it looks with containers activated in this project. First thing you can notice is that the scan table now has a new feature. It's got a run menu, and you can see that there are now containers that we can run on each of the individual scans in this session. So we could run these containers individually, but we could also select them in bulk and run them in bulk, which is a more efficient way to do things. And what we want to do first is convert these scans to Nifty. So let's select the DICOM to Nifty container. So a helpful bulk launch dialog opens. And so I've got a little menu here just confirming this is the action that I want to take. I click yes, I want to run the containers. And the result that I get back is that each of these containers have been queued for launch. So XNAT Container Service does come with a built-in job queuing, but and this is not running in a Docker Swarm type environment. And we can see here we have a little view of background processes. And you can see that a couple of these failed right off the bat. This usually means that something went wrong in the command resolution. It couldn't find a resource that it was looking for. And the message kind of supports that. It's telling us to look at the JSON path matchers in the command. Oh, and now we've got more failures. What's going on? So if you remember, the JSON path matcher in the command JSON is looking for a resource named DICOM. So why did those scans fail? This one here, 80640, does not have a DICOM scan resource. Its scan is called secondary. So this is a secondary capture. And this means that even though the files within are DICOM format, it means these scans probably shouldn't be used for this kind of analysis. I think we can safely ignore these errors. But then what happened with scans 4, 5, and 6? So I wanted to figure out what was happening with scans 4, 5, and 6. And after doing some investigation, I found out why these were failing and what we can do to fix them. And the way that I found it out is probably more interesting to you than the actual solution itself. So what I did is I came down to the history table, and you can see that I tried rerunning the container several times. In each time it failed. So what you can do to look for insights is go into the failure reports, and you can see that we have access to both the standard error log and the standard out log from the completed container. So even when the container completes in an error state, it still returns you some useful information. So if I look at the standard error, it's giving us some information. There's obviously something going wrong, but I don't know what to do with this. So I'm going to look at standard out instead. And you can see here, this is actually interesting. Slices not stacked. Use merge 2D slices option to force stacking. And so that would indicate that there's probably some kind of command flag that I could use with my DICOM to Nifty command. So what I did is I searched up DICOM to Nifty, or DCM to NIIX, and merged 2D slices, and I found this issue here on GitHub in the Rorden lab. And this is where the executable for DICOM to Nifty came from. And you can see here somebody else is seeing the exact same problem we are. And the response is, let's run the conversion again with -my as a parameter. So that would be an ideal use case for the other options flag on this container. So we just need to re-enable it in the project. So if I go back to my project settings, go to my run DICOM to Nifty on a scan, and set defaults, I want to make this other options user settable now. And what that will do is give us the ability to run these scans in bulk, and I want to use -my as my other options parameter and relaunch these containers. You can see this flag was picked up and is being passed on. And we can actually view the process down here in the history table as well. And we can see one of these is already completed successfully and 2 others are in progress. Keep hitting reload and you can see that there's additional progress being made. And success. All 3 of those scans successfully processed. And we can view that if we reload the page here. Looking in the managed files, and there are our long lost Nifty resources on scans 4, 5, and 6. So it's obviously useful to be able to run containers all at once on several scans within one session. But what we really would like to be able to do is run containers across multiple sessions in a project. And that's what the batch launch plugin gives us. And I'm actually going a step beyond that even, because in this demo right now I'm running XNAT 177 internal, which lets me activate the CT scanned data type, and then I can batch run containers on the scan level across multiple sessions in a project. And we do that by going to the processing dashboard here in the actions box. Find your scan that you're looking for, scan data type, and get a list of every scan in your project. And you can see here we have a notion that's on this page of scans that have already had processing done. We don't necessarily want to rerun those, so we can filter this table based on the ready state. And then we can select all of those. Select the DICOM to Nifty scan job and launch them. Now we have another bulk launch menu. This time we selected 29 items across multiple scans, and we can run those containers. And again, these have been queued for launch. So XNAT is going to pick them up off the queue when there's processing resources available and attempt to run them. And you'll notice that we didn't set any command line flags on our Docker command this time. And so I would expect to see some additional failures here from those scans that had the stacking issue in the DICOM. And that's something that we'll see in this process. And what you would do is go back and rerun any of those failed scans with the command line, with the command flag -my to resolve those stacking issues. But I don't want to run all of my containers with that flag in place because I don't want to mess up the scans that work without it. What would be really cool would be to have some means of scripting that flag on or off based on the contents of your DICOM scan, but that goes a step beyond any behavior that XNAT can currently support. And yeah, now we're starting to see a couple of these scans fail as expected. That's fine. Let's just fast forward to the completion of this process. Okay, so our processes are all complete, and you've got a mix of up here of successes and failures. We can reload this table and see, there's our failures. And we can filter on these failures, and we could target these for reprocessing with that extra command line flag, but we won't do that right now. So what we can do now is take any scan that was completed successfully and select all those and launch our nifty to lung mask job. Now this is a bigger container, so you have to be wary of how many processing resources you're willing to use when you're batching up a series of containers. So perhaps rather than launching on all of these scans, I'll just launch on a few. So I'm going to queue these 4 scans. And you can see here that this container expects nifty resource, and it expects to find nifty file with the appropriate name. But our name here is $nii.gz. And it says we're being warned in advance, bulk launch is likely to fail here. So perhaps we should cancel out and make sure that our data is matching the format that this container expects. And you can see our converted nifty is named .nii. It's not returned in a gzipped format. And so what we need to do, again, is change something in the command definition that will allow it to work with our file format. So we can go back to our project settings to do that. Here's our lung mask command, and we can set our defaults. And here is the matcher that looks for a nifty file. We can simply change this to say, don't look for nifty.gz, look for nifty. So let's try this again. We're going to filter on completed, and we're going to filter on just these set of scans here. And we'll run nifty to lung mask and launch the job. And you can see this is happier. It's already finding files that match the matcher and is not giving us that ugly warning anymore. So I feel pretty confident about being able to launch these in bulk, so let's go ahead and hit run containers. Container successfully queued. You can see here, this is what our output file name will be. And now we have a new set of background processes. We can kill this old one. And we can monitor how these processes are doing. And that's a bad sign. A 502 gateway error usually means there's some problem with server communication. We can try reloading this, maybe we'll get a better insight, but no, I think we have crashed our XNAT. Yeah, there it goes. We've run out of memory and XNAT Tomcat server has crashed. So what's just happened is that I've given an object lesson in what not to do. Most notably, don't try to run bulk operations that are very expensive in terms of memory usage on a low-level system. You know, this is where XNAT administration and DevOps really need to come together to determine what can be done, what can be supported. And when you're planning to run more expensive operations, particularly in bulk, then that you need to be thinking about a more heavyweight enterprise level environment that you can do that activity in. But let's log in and see what happened here anyways. If we go back to our processing dashboard, we can see 3 of our operations failed as you would expect, but one of them actually completed it. So let's take a look here at the one that completed. And let's see, so this scan here successfully got a mask created. The second one did not. We go to Manage Files. We can see here is our mask resource, and here is the lung masks _cove.nii file. One downside of XNAT is that we don't have a built-in nifty file viewer, but I can download this nifty mask just to proof it, just to make sure that it generated something like what we wanted. And I can open up a Papaya image viewer. Just drag that nifty file into the viewer. And yep, you can see here we actually have a 3D volumetric mask. Left and right have been given different shade values. So yeah, our container ran successfully and generated a usable output. So I mean, I think this shows you the power of container service, but it also shows you, with great power comes, the rest.